least finish the first part before you start marking some stuff and leave it till after. For each of these functions, inside, outside function here, something squared plus 9. The outside function is cosine of that, right? This one here you have the inside function is something squared plus 10. And this is something or other to the 15th power. Tangent of sine of x. Don't mistake this for tangent times sine x. It's tangent of sine of x. So for those of you that are having trouble settling down, please settle down. Okay? And this is tangent of that. This last one, at least one or two of you were asking and saying, how do we do that one? This is not a composition of functions, right? Not a composition. So there is no inside and outside, right? If you knew what x was, you'd figure out what the tangent is, what the sine is, and multiply them. It isn't that you'd figure out one and then take that answer and do this, right? So make sure you understand the difference there. There's no inside and outside there. Maybe we should have written something else here. Right? Now I want to, because I really can't remember what this was or why I put it on here, but I want you to have a look at this. Okay? Maybe if can't have a link in the video, but we can at least pause it there. So what you need to think about here then is look at what the derivative is when it's all put together as a single function, because those are the same, right? 2 bracket 3x minus 5 is the same as this one. The derivative of this, what's the derivative of just that linear function? It's just 6, right? So the derivative of this is 6. Think about what the derivative of each of these is. I've chosen linear functions because then it's easy to see the relationship. This causes some kind of change, right? There's some kind of rate of change involved there. There's some kind of rate of change involved there. The derivative of y with respect to u, if u is the variable, what's the derivative of that? It's 2, right? And what's the derivative of u with respect to x? Meaning that function, what is it? You're being cheeky? Not sine of 3, no. We'll get back to that in a second. This is by no means a proof or anything of this. You can probably see how these are going to be related here. Right? The derivative of y with respect to x. If you have y is related to u and u is related to x. If this is 2 and this is 3, then the derivative all the way to there is going to be 6. If this was, think of it as, I don't know, if we had, on a photocopier you can push a button, and let's say this was one single photocopier and this was another one. The first one enlarges it 300%. That's kind of the rate of change, right? It's a constant rate of change. And then the next one enlarges it 200%. So if you start with some picture and you put it into this one, you push that button, it enlarges it 3 times as much. And then you take that resulting picture, okay? You don't start with the original picture. You start with the image that came out of that one, and then you put it into the second photocopier, and you come up with an image here, okay? That is the same as what overall change here? 600%. Okay? It's the same. If you want to know what's the overall change, you can look at what each change is separately. That's what the chain rule is. So if this were a really complicated function to work with, or if it's presented as this, like your choice in finding the derivative here, I'm pretty sure most of you, to find the derivative of that function, would just multiply it out to give you that function and say that it's 6. But you could just say, what I have here is, making a mess of this, what I have here is 2 times something, and then the something is 3x minus 5. So what you can think is the derivative of the outside function with respect to whatever the inside function is 2, and the derivative of the inside function with respect to x is 3. This is outside. What's the matter with you guys now? Right. You have to see that you have a chain of functions, and when you're looking at derivatives, it's fine when I've broken it apart for you here as 2 different functions. But if it's written like this, you have to see it as when you have y equals 2 times 3x minus 5, you first just have to see it as I have 2 times something, but I'm going to ignore what's inside first. If I have, exactly, you see it as 2 times something that you don't care about right now. And you look, it's first the derivative of the outside function with respect to the inside. You just pretend that this whole inside function is the variable. You don't think about what is actually inside there, but you just think 2 times something. The derivative of that is 2. And then after that you look at the inside function and you ignore the outside function. And you look and realize that the inside function is 3 times x minus 5, so its derivative is 3. It isn't multiplying the derivative of the whole thing. You got to ignore the inside function first. dy dx here then, you look at the derivative of the outside function compared to the inside function. And then you multiply that by the inside function compared to dx. It makes a whole lot of sense. I mean, once you look at this, it makes a whole lot of sense. If you have the photocopier thing, or if you have some gears turning, like you have one gear and it's turning another gear and another gear here, it's, each one, there's a certain ratio between each one. The overall ratio is going to be whatever those 2 ratios are. If you look at the ratio of those 2 gears and the ratio of those 2 gears, the overall rate of change or ratio is going to be the combination of those 2 things. This one compared to this one and this one compared to this one. Yes?
So is that the chain rule, or like if it was like 2 over 3x minus 5, would it be both sides divide by the
2 over 3x mines 5?
Like is it always going to be multiplied?
Well, this is, I know that this looks like 2 times that, but you could think of it as one function is 2 times something, and the other function is 3 times something minus 5. So if we think of it as, if you think of the outside function as sine of, we're getting ahead of ourselves here, but if you think of the outside function as sine of something, and the something happens to be 3x, like in that video, right? You first have to just say, I have sine of something. What's the derivative of sine of something? Cos of that something, which is, you could put it in there, right? It's cos of 3x. But you have to multiply it by the derivative of the inside function now, which is 3. So in that video, it's going to say the derivative is 3 times cos 3x, not just cos 3x. You have to do the derivative of the inside.
I got pretty close.
You got pretty close. All right. Let's